Okay, welcome, Jacqueline and Allison and Mary and Esther and Alonzo and Alejandra and Alex and Nick and Brenda and Hannah and Bridget and Constance and another Bridget, same Bridget, and Raquel and Phone. Thanks for coming. This is our first regular statistics webinar for the quarter. This is not like the orientation at all. So first thing is, it's better to come live, but it's not a requirement like the orientation webinar. But I do want to remind you, if you did not attend the orientation webinar live, I sent you an email, and that means you need to take extensive notes watching it and then submit the notes of at least 5 pages. So if you're one of those, then I emailed you or I contacted you today using your college email, and you know who you are, and that has to happen, because that's how I decide who has attended the class, because I'm required to drop students who have not participated. And that's my measure of participation. So that is required for the class, is to do that. But hopefully, you know, most of you, of course, attended it live, and then you don't have to worry about it, you're there. So that's the plan today. Is we're going to do chapter 1 and 2, and I want to let you know that there are a lot of little details in chapter 1 and 2, but nothing hard. So I'm not going to be able to do everything in chapter 1 and 2 because there's just too many little details. So you are required to read the book in chapter 1 and 2, and also watch the other video on chapter 1 and the video on chapter 2, because they're longer than a webinar. And that is a requirement to be able to succeed. So that's important. I want to tell you a few more things, and that one of them is that this is the week that you're supposed to get Project 1 partners. So a lot of you have already gotten it. You've gone online and you've gone to the Project Discussion Forum, Project 1 Discussion Forum. You found your partners, you're good to go. Hopefully you have 3. If you only have 2, please be accepting on a third person that wants to that's looking for a partner. You're helping yourselves and you're helping the other person. So 3 is better than 2. If you already have 3, you're done. And then you can't be accepting because you're done, you got your 3. So that's just a big note. Post on the Project Discussion board saying I need a partner if you haven't already done it, and then you'll find partners. That's really supposed to happen the first few days, because a lot of the project is what we're doing today. Okay. The other thing is I want to remind you on Thursday, which is just in 2 days, your 2 posts, your initial posts are due. One is very easy. Where can you find the textbook? So the easiest way to find the textbook is to go to the Canvas site. You go to the syllabus, and you'll see the textbook link. I think I have the links in another place too. If you go to the module 1, which is, or I might even call it module 0, but it's the first module before week 1. There's a link to the textbook there also. So Hannah, hopefully that makes sense. Otherwise, I can show you if you need it. But that's the easiest way. You can also post in the Q&A forum, say where's the textbook, and I'll post a link on the Q&A forum if you still can't find it. Because the Q&A forum is a great place to ask questions like that too. But for now, those are the different ways of finding it. Okay. And again, one of the big points about the webinars is that you can ask questions and I'll answer them right away without you having to wait a few hours. And that way we can actually have a conversation instead of kind of disjoint question and answer kind of stuff. So this works better. So please ask questions. Again, chat box is fine, talking is fine, whatever works for you. So let me tell you what we're doing today. Oh, one more thing with the harder discussion post. One person was having trouble, and they posted in the Q&A forum, and I gave suggestions. I'm going to let you look at that. If you go to the Q&A discussion board, you'll see some suggestions on where you might find some articles that talk about how they conducted a survey. And I gave a pretty good list of like a bunch of places that you might go look, and most of those have their survey design explanation in their article. Okay, I'm not telling you the article, I'm telling you resources to find articles. Okay, so that's just one more thing to note. So what we're doing today, I know this is going to sound really silly because of the name of the class. We're doing statistics. That sounds silly? So statistics really mean that you collected data and you've taken that data and you have summarized the data by special numbers. Some of those numbers you already know from 4th grade, like the average, right? I hope you all know the word average. You've all heard that before. That's one of them, and that's one you've all seen before, and hopefully you all know how to, you get what it is. In this class, we call it the mean, actually. Don't shoot the messenger, that's what everyone calls it in statistics. So the average for this class is, we're going to use the word mean, and I do want you to use the word mean when you're writing a project, for example, and not the word average, because that's the statistics terminology. And terminology is a big piece of this class, and especially the first chapter. So we're going to be looking at statistics, and there's some issues, and they're not easy issues to deal with. One of the hardest things, maybe the hardest thing in statistics, is how do you collect data? So I'm going to give you an example. I always like to go to like a current event or the news page, and I know not all of you from Tahoe, but I grabbed our local newspaper because I can always find something, which is nice. So I grabbed our local newspaper, so I'm going to share my desktop. And this is the Tahoe Daily Tribune. If you're in Tahoe, you've probably heard of it. It's our main or one of our main news things. And I'm not even going to look at the article. I'm going to look at towards the bottom. And they have a survey. And actually, let me open chat, make sure I can see what you're doing. There it is. So they have a survey, and I have a rule in the class. When I ask you something, a survey, you have to answer it. But if you don't feel comfortable, you don't have to tell the exact truth. Just something somewhat reasonable. We just need data for this class. This one, I can't imagine anyone not feeling comfortable about your answer to this one. So, how are you feeling about all the snow we've received? Now, if you don't live in Tahoe, you can imagine living in Tahoe. And your choices are enough with the snow, bring it on, we need all the snow we can get, or don't care because I'm a shut-in. I'm on my smartphone all the time. I never leave my house. So I want you to put in your chat box. We're going to vote, and we're going to decide which one to choose. So choose your answer. Bring it, don't care, bring it, enough with the snow. Wow, we're mixed. Enough with snow, bring it. Enough of the snow, we're tied on enough of snow and bring it. Enough. Bring it, enough. Enough. Okay, I think there's a little bit, wow, it's almost even. I'm going to call it enough because, again, I don't want to spend all day on it, but it's very close. I'm with enough. I love skiing, but I'm done. So I'm going to click that, and I'm going to hit vote. Oh, I already voted. Okay, let us refresh then. I don't remember voting on this one. Huh. Maybe someone at the college voted and is looking at my IP address. I'm going to view results, which is good enough. Okay, so what we've got is we've got 59% say bring it on, and then 39% enough with the snow, and then 3% don't care. Okay, so the first thing is I want to look at the survey question and want to mention something, and this is called a qualitative variable. Have you heard the word qualitative before? Just in English. Anyone heard that word? I don't. Yeah, what does it mean? You all say you heard it. Okay, it's a good guess as numbers, but it's actually the exact opposite. It means it's not numbers. So it means that the answer to the survey question is not a number, right? In this case, the answer to the survey question was enough with the snow. That's not a number. Is that clear? So this is a classic qualitative survey question. And qualitative means that you have words as your answer and not numbers. There's actually a special kind of qualitative survey question that this one is not. And I like to use the easy way of describing it, which is the yes-no question. And I'm sure you all know what I mean by when I say that. So it just means there's two choices, and it's yes or no. Okay, and sometimes the answers aren't the words yes or no. Sometimes it's, lived or died if you happen to be a doctor, for example. But that's they live? Yes, they live. No, they did not. So if it's a yes, no, it's kind of a special qualitative. This is more of just a regular qualitative where it's just words. Whereas had it been a quantitative survey question, then the answer is a number. And that would be more like, how much snow would be your optimal amount of snow for a winter season? Because if I asked you that, your answer might be 7 feet of snow. Does that make sense? And it's a number. So if it's a number answer, we're going to call it quantitative. Can you remember that? Because those words are important. And throughout this entire course, we are going to be dealing with qualitative survey questions, yes-no survey questions, and we're going to deal with quantitative survey questions. And we're going to treat them differently. And if you're confused about what it was, you're going to get an entire problem wrong for the rest of the class. Every time you do a problem, it's going to go badly for you. So it's really important whenever you're looking at a study that was done to think, is this qualitative? Is it yes, no? Or is it quantitative? Does that make sense? Any questions on that? It's actually not that hard a concept. What's hard is to force yourself to focus on it. So promise me you're going to focus on that for everything we do in the rest of this class. Okay, now comes the hard part. Okay, I don't think those 3 words were that hard. All right, so we got a vote. 59% said bring it on. Looks like most people like bring it on. Does that mean that most people in Tahoe want to bring on more snow? As it snowed this morning. That's why I brought this one, because we got a little snow this morning. So I thought, let's do the snow question. Does that mean that most people in Tahoe say bring it on? Okay. So Brenda says no, not really. And why not? What's the problem with saying most people in Tahoe? Depends on who tastes it. Okay. All right. This is very interesting. Okay. It turns out, and this is not something I expect you to know, the sample size is not too small. Avi's got the right answer, is that sample is biased. And biased means that the people likely to answer this question don't represent the people in Tahoe. The people likely to answer this question might be more likely to be enthusiastic about snow, for example, because they read this in the first place and they love the snow. And that might not be true, but there's a possible bias. And the bias, one of the biases in this is what's called voluntary response bias. And what that means is that the people they asked are the people who wanted to do the survey. That's who took it. There was no incentive. There was no way. There was no like scientific way of getting specific people. It was just whoever wanted to do the survey. We call this a convenience sample. Okay. Again, it turns out having 1,000 actually is plenty big, because we got 620 yes, bring it on, 406 enough. So we got a sample size over 1,000. And that's actually plenty big. Later in the class, we'll actually do some calculations, and we'll realize that it's a big enough sample. Okay, and that's one of those, I'm just going to tell you for now, believe me, okay, that it's a big enough sample. The issue is the sampling technique is convenient sampling. Okay, so now comes the very hard question. If you were to do a study of, let's say, 1,000 people, I'm just going to round it to 1,000, and you want to do, say, 1,000 people in the Tahoe area, who would you select? Which 1,000 people would you choose? How would you do it? Any suggestions on how you might actually find the right 1,000 people? Because you're going to do a survey. Okay, so let me go and start with Alejandro's idea, random. Okay, so I want to give you a very, very big concern. beware of ever saying that you did something using random sampling. Because the only way to do random sampling, okay, as kind of Mary says, Mary calls it draw names out of a hat. That's old school. Nowadays, it's let a computer pick the names. No one draws out of a hat anymore. They let a computer pick the names. But here's the problem. There's two problems. Where do you get the names? How are you going to get the names of everybody in Tahoe to put them in the hat? Okay, and the answer is you can't. Okay, there is no set of names that exists. Maybe the police have it, but I don't think they even have it. So there is no way of conducting a true random sample. And that's true for almost everything. Very difficult to do a random sampling. So again, random sampling means that literally you got a list of everyone in the population. Good luck. And then you did the hat, but more likely you used a computer. You could ask Alexa or Siri. Okay. And by the way, I'll try that with your smartphone. You could. I'm going to try something just fun. Okay. I'm going to ask you to pick a random number, but don't do it. Don't put it in the chat box yet until I tell you to go. Okay. To pick a random number between 1 and 4. Okay. So 1 to 4 and an integer. Okay. A whole number. And I want you to just right now, just without looking at anybody else, pick a random number from 1 to 4. Got it? Y'all thinking about it? Okay. Now put it in. Everyone says 3. Everyone says 3. Almost. Okay? It always happens. Even if you think you can pick a random number, you can't. If it was a random number from 1 to 4, we shouldn't have almost all 3s here, should we? Okay? This always works, by the way. Okay? It's something, it's a psychology thing. I'm not a psychiatrist or psychologist, but I do know that there's something about psychology that makes everyone pick 3 or almost, except Alex and Julianne did not, okay? But everyone else picked 3. Actually, Jacqueline didn't, but almost everyone did. So if you think you can pick your own random number, you can't. But here's who can is if I go home and I say, hey, Google, give me a random number from 1 to 4, I will get one. Okay, computers are very good at that. Or if you go home and it's Alexa or Siri or whoever you got to do that kind of stuff for you, they do a really good job on random numbers or random names. Okay, that you can do. So that is the only way you're going to get a random sample. And it's almost always impossible. Any questions on that? Okay, so then there's other ways. Okay, I saw in the chat, someone suggested cluster. Okay, I don't expect you to know what that word means until the end of this day, and then you're going to need to know. So a cluster sample, what that means is you're going to identify kind of specific groups or locations in your population. And there's going to be maybe many of them. So you might look at, say, the clusters might be the, say, streets in all of the Tahoe area. That you can very easily get on the computer. Okay, Google Maps can get that for you, for example. And you can get all the streets. And then you can use a computer to say, pick 20 streets in the Tahoe area. And then you go door to door. And it's still very hard with the volunteer response. So you're going to have to actually have a lot of money to pay people to do that so that they can keep going door to door, maybe offering them each $100 if they'll answer your question. Most people will say yes if they're offered $100. Would you say yes if you're offered $100 to answer that survey question? If someone knocked on your door and they had a $100 bill in their hand? Okay. Yeah, I guess everyone does. So volunteer response, if you give an incentive, then there is no volunteer response bias. And that, I actually had that happen to me once. It was so awesome. They gave me $100 to do a survey and free lunch. It was cool. I went down, got my $100 and did the survey. No volunteer response because we were all really happy. Okay, so that can happen. So that's called cluster sampling because you're asking everyone in the chosen clusters that represent the community. Okay, if you wanted to say, let's say your population, instead of Tahoe area, let's say your population was community college students in California. What are the natural clusters? There are natural clusters for community college students in California. Any thoughts? Freshman, sophomore is a little too big because there's like 500,000 or 1,000,000 freshmen. Good luck going to get all of them. Yeah, classes is a natural cluster. So for example, this class is one of the clusters. And there's thousands of them, but those can all be, say, you can pick those. And you can pick representative clusters, maybe some online classes, some evening classes, some day classes, some transfer classes, some recreational classes, so that they are a representative sample. And then you go survey in each of those, say, 10 classes that you picked. And it's a lot, with students, it's pretty easy, especially if the instructor is asking the survey question, to get them all to answer. And that's another cluster sample. Okay, so that's one way. Let me give you some other ways that are commonly done for sampling techniques. Let's suppose you were worried about, you were going to ask this question about the snow, and you might worry about age bias. So one of the problems with convenience sampling, for example, is surveyors tend to ask people like themselves. And that's been studied and they found out that's true. So what you might want to do is make sure that you don't have a bias on age, because age probably has a lot to do with whether people want more snow. So maybe not, but that's my guess. So then what you would do is you would look at, say, age categories. And the first thing you do, by the way, I want to mention this for your project too, is don't even think about children. I know that sounds mean or whatever, but when you're doing your project, for example, when you're going to have to ask a survey, don't ask children, okay? And the reason is there's all kinds of legal issues with surveying children. So in this class, we're not doing it. So we're going to look at adults, 18 and over, and 18-year-olds probably have a very different feel about wanting more snow than, say, 65-year-olds. So you're going to maybe go online and find out what percentage are there, say, between 18 and, say, 25, maybe between 25 and 40 to 60, and then above 60. Any questions on that idea? So you're not going to necessarily ask the same number of people from each of the age brackets, but the proportionate number of people. So if you found out that 30% of all the people in your town were senior citizens, and you wanted a sample size of, say, 300, then you'd then you'd ask 90 senior citizens, because 30% of 300 is 90. Was that math too fast, or is that clear? And you would establish quotas, and then you would ask that number from each of the age brackets the survey question. And what you're doing is you're guaranteeing that you don't have age bias in your survey. Sometimes you do multiple stratification. You might want to choose age bias, maybe you might want to choose gender. Maybe genders are different in the survey question. So you research the percent of each gender. And by the way, it's not always 50-50 for gender, so be careful. There are more female college students, for example, in California than male college students in California. That's an example. And in Tahoe, there's actually more male college students than there are female college students. Okay, anyone know why, by the way? Why Tahoe is different? Some of you live in Tahoe. The hint is, the students that make it different, I'm hoping you will not go and be their neighbor. That's a hint. I'm hoping none of you are going to be their neighbors. Any thoughts? I don't see you all jumping in with the ideas. Okay, let me tell you, we teach in the prisons. It's not the weather, we teach in the prisons. And there's a lot more male felons than there are female felons, and we have a lot of prisoners that we teach. That's one of our little niches that we've got. So that's why we're more men than women in our college. But for normal colleges, there's more women than men. But you find out, and it's pretty easy to find out what the percentages of whatever you're looking at of male and female, and then you multiply that percent by the sample size, and that's your quota. Any questions on that idea? Okay, there are some other techniques of sampling. Let me give you one more that I are going to definitely make you responsible for, and this is especially done in manufacturing. So let me give you an example. And this was a former student of mine asked me for help, and he was a towel manufacturer. He has got a big factory in Vegas actually, and he makes towels for hotels. And he wanted to show that his towels were better than the ones made in China. So he wanted to randomly sample towels that come out of his factory. So what I suggested is we do what's called systematic sampling. So what he did is every 100th towel that got produced in his factory over the study time got pulled out to be examined and tested to see how good his towels were. I won't go into the details on the testing. And if you do something like every 1,000th towel, then that's called systematic sampling. Okay, that only works when there's a lineup of the population. If there isn't a lineup of the population, you can't do systematic. Any questions on that? Any questions? Okay, so that's the main thing I wanted to talk about sampling techniques. Again, sampling techniques are the different ways of collecting samples, and your goal is to not have bias. So what kind of sampling is the worst kind of sampling for a good study? See if you remember. The hint is it's the first one I talked about. No, random is the best. It's the hardest, though. Yeah, so I want to let you know. So Abby got it. It's convenience. Alejandro, you almost got it, but don't make that mistake. Convenience, not convenient. Okay? So convenience sampling is the worst kind of sampling because you're just doing whatever's easy. You almost always have horrible bias. Okay? So again, you should always worry about convenience sampling. Voluntary response bias is another bad one, and that's always part of convenience sampling. Let me give you an idea of an ultimate fail that involved voluntary response bias. And here, see if you can remember what happened about a little less than 3 years ago. It was the most important survey that happened in the last 5 years. What was the big survey? Now, census is every 10 years. Yeah, the election. And I don't know if you remember, but in the news, in late October and early November, what did they all say about the election 2.5 years ago or so? They didn't say it was a cheater. What was their conclusion? Not rigged. That's what Trump said. Yeah, Hillary was going to win. All the news articles said Hillary was going to win. And they said that based on a survey. Okay? Any guess on what went wrong? Okay? I hope you know that Hillary didn't win. No, but even given the electoral college, they said Hillary was going to win. Hillary was way ahead in the polls in the survey. Anyone know? Yeah, there was a voluntary response bias. The problem is that the way all the surveys were done is they were telephone surveys or internet surveys. And private type people were more likely to vote Trump. Okay, people that said, get out of my hair, those are the Trump voters. And what ended up happening is the survey results did not represent the population at all. And that was because of voluntary response bias. So that's like a classic fail in surveying. And do y'all, I don't know if y'all remember that, but I promise you that happened. And it was something that I had a lot of concern about. And it, you know, in terms of them failing. Okay, there are other fails also that have happened. Okay, I have actually personally helped in the last election figure out who the public wanted, and I found their fail and changed it. Okay, and that was my personal thing about our local election for Congress. Okay. The American election, Trump got less votes, right? He did get less votes, but if you looked at the polling data, he was supposed to get so many less that Hillary was going to win. Does that make sense, Alex? Yeah, so the polling data said that he was going to lose the Electoral College. So there were a bunch of states that went to Trump that they said they were going to go to Hillary Clinton. Okay, so you're right that there was the Electoral College and Trump still didn't get the majority, but the percent that he got was much higher than what the polling data said. Okay, so now what I want to do is I want to talk about statistics. And again, what statistics are numbers that you get from the sample. Okay, and if you, instead of look at the sample, look at the population get numbers, those are called parameters. So don't forget, statistics are from the sample, parameters are from the population. Usually, parameters you're never going to get, but that's your goal, and it's kind of depressing. Okay, it'd be really nice to know say the percentage of people that are maybe in favor of the border wall. But we're not going to ever find out the percentage of all Americans that are in favor. So all you could do is do a survey and then collect data and then come up with statistics based on that. Any questions on that idea? Okay, but I'm going to do a quantitative survey question. And again, the rule of this one is you have to tell me an answer. It doesn't have to be perfect. You don't have to spend an hour figuring it out. I'm going to ask you just a survey question that's probably not very personal, but I need to change my share because I want to do it with my calculator. Okay, so data, so it's not data and statistics, it's parameters and statistics. So parameters come from the population, statistics come from the sample. Does that make sense, Julianne? Yeah, so that's the difference. Data is the numbers you get, all of the numbers. Not statistics is a summary of the numbers. Data is just all of the numbers. So what I'm going to do is I'm going to ask you a survey question, and I want you to put the answer in the chat box. I'm going to do my best, and I'm going to show you how to do this on the TI-84. And this is the TI-84 plus CE is the one I've got. The one you'll see in the other videos is the older version, so you kind of get both of the TI-84s. Okay, 83 looks like the older version, by the way. So I'm going to go to stat, and again, what I recommend on these webinars, if possible, is to bring your calculator with you so you can follow along. You'll learn a lot more if you're hitting the buttons while I'm hitting the buttons, because we're going to do this a lot. So I'm going to go stat, and next I'm going to go to edit, which is number 1. All right, next I'm going to hit the left arrow to move on to the first column, and then the up arrow, so L1 is highlighted. The next thing I'm going to do is I'm going to hit the clear button. By the way, tell me to repeat if there's something you're not following. But this is really important because it's going to be how we enter data into the calculator. Then I hit enter. I want to give you a huge warning. This is My biggest qualm about this calculator, never, ever touch the DEL button when you're doing this. Okay, if you do, you will be in tears. Because if you do it, you have gotten rid of L1 forever. And getting it back is really hard to figure out by yourself. And you'll need to talk to me in my office, okay? Or Zoom or something, and I'll show you how to do it. But don't touch that DEL button. It's really hard to get it back. So it's the clear button, so just remember that. I wish they didn't have that button there because it shouldn't be there in this case. There should be a big warning. Are you sure you want to destroy your whole calculator? Okay, once I've got that, now I'm gonna ask you a question. And the survey question is, how far in miles from Lake Tahoe Community College are you right now? And again, I don't expect you to know the exact answer, but just to give you an idea, Los Angeles is about 500-ish miles. Sacramento is about 100 miles. San Francisco is about 200 miles. Say Barton Hospital is about a mile. Okay, so okay, good. So you're typing them in. And what I'm going to do is I'm going to start typing them in. So 8 was the first answer. Enter. And again, if you don't feel comfortable, just give me a number. It doesn't have to be true. But if you do feel comfortable, give me. Okay, and then 500. Side 500. Enter. 400. Enter. And then 200. Enter. And let me scroll down a bit. Then 150, 201. Abby, you might be my neighbor because I live about a mile from campus, 0.8 miles actually. And then we have 100. And there's some more. 771041. Got some Myers folks probably. $170. To 130, 230. Okay, so we have our data. So I want to let you know that some people get frustrated by this because they love mathematics, and I'm not going to go into the deep mathematics on how the calculator finds all the statistics. So I apologize if you're nerdy like me and you love math and you're already done like 2 years of calculus or something like that. We're just going to trust the calculator that it does everything right. Okay, on the other hand, most people are really happy. Can you show how to get to the chart from our calculator? Yeah, so what I did is I hit this stat button right here, and then I hit enter. And that will work on all of the TI calculators, at least the 83s, 84s, 80, not the 89s, 83, it's 84, and I think stats, and Nspire. If you can't get this, if your calculator doesn't have this, you need a different calculator. Okay, then I'm going to hit the stat button one more time. Now I'm going to go to calc, means calculate. Okay, we only have one variable because it was one survey question. Is that clear? That's going to change later in this course, but today it's just one. So under one variable statistic, I'm going to hit enter. I want to let you know, depending on the type of calculator, yours might look different. This is the newer version. So it has a menu, and the list is L1. If it doesn't say L1, you type in second one, enter. Frequency, I believe, is empty, clear, because this is not a frequency table. And I go down to calculate, and I hit enter. If you have the older calculators like the T83 or one of the older T84s, okay, if yours went to a screen that said one way in Nova, then you didn't hit calculate, you hit stats. Or tests, sorry, tests. You need to make sure you're hitting calc. So David, you hit tests instead of calc. So try again. Go to stat and then go to calc. And make sure that you're on calc before you hit enter. So now I'm going to hit enter. And it should say one var stats. Okay, so now there's a lot of stuff here. And a lot of these numbers are really important and some are not for us, for our class. So let me go through each of these things that we've got. The first thing is this X with this bar on top. The official name for it is X bar. Okay? And so if we're considering this a sample, then we say this is a sample mean, or X bar. And what we got was 138. Now, what is the easy word that like every fifth grader knows that means the same thing, but the fifth grader uses a different word? What word do they use? Yeah, average. Okay, but we need to use the word mean, and in particular, I want you to say sample mean. If we're thinking about this as a population, like the population of everyone who showed up today, because we did get everybody, then we don't use X bar, we use a Greek letter mu. And the way I like to remember it is I have, in fact, let's see if you can see. Here's my phone. Can you all see that? That's my cat. And she says, she talks about this all the time because she says, mew. And that's how you say it. The way you write it is, let's see if I can do it. I think I can. I'm going to go annotate. It kind of looks like a mew, except it's like a cat. So it's got a U. It's like a cat, though. So it has a tail. And that's a mu. So if it's a population mean, then we use the Greek letter mu. If it's a sample mean, we use X bar. Any questions on that? Okay, the next two we'll never use, so I'm not even going to go there. But the fourth one is really important, and that is, I'm just going to say S because that's really the official. I don't know why they put an X there. They shouldn't. It should just be S. And that is called the sample standard deviation. And you'll notice that if you compare that to the mean, it's bigger. And what that tells us is that the data is very spread out. So you guys are all over the place in terms of how far you live from Lake Tahoe Community College. We had people that were 500. We had someone that was 1 mile, or how far you are actually. Does that make sense? So if you have a very big number, still can't get to the screen. Okay, let me show you again. If we hit stat, calc, enter, I'm on the screen. I'm going to go down and enter again. So I'm not sure if that helped, but that's how I do it. Okay, so that should work. If you have the same calculator, it's going to work. Okay, so this standard deviation, it's essential. You will not pass this class if you don't understand the standard deviation. Do I see the video feed? No, I don't. I only see because I have it on my screen, so the video feed doesn't show. Sorry about that. Yeah, there is videos on it. YouTube's got them too, but I have some where I do it. That might help, where I do it a little slower. And you can check the kind of calculator you have and see how to do it, because you might have one that's slightly different. And that's possible. It's hard to help you when I can't see it. Sorry about that. So the standard deviation is really, really, really important because it tells us how spread out everything is. Any questions on that so far? Okay, so let me give you an example. Okay, let's say that my goal in this class was to have a really good pass rate. Okay, I want a really large number of students to pass this class. Okay, which I would love to see. And remember, a pass is over 70%. If I told you that the average course score at the end was 74%, did I reach my goal or not? Any thoughts? Okay. So it was a trick question. None of you have the right answer. The answer is you can't know from what I just told you. Because if the standard deviation is really small, let's say 0.1, then just about everyone got a 74% and everyone passed the class. Do you see that? But if the standard deviation was, say, 25, then I might have failed half the class because you're going to have a whole lot of low students. Do you see how that is? So the spread gives you a lot of information. The standard deviation gives you a lot of information that the mean does not give you. Any questions on that idea? Okay, the next one, sigma sub x. That is a population standard deviation. It turns out they're slightly different. That's why the calculator has to have them on separate lines. So S is the sample standard deviation, and sigma is the population standard deviation. So let me remind you, S is a statistic, sigma is a parameter. And the calculator doesn't know whether we're treating this as a sample or a population. So it's just going to give you both. And you have to know which one to look at. N equals 16. I bet you can all guess what N represents. Let's see if you can type in the chat box, because that's an easy one. It's important. Total, not sure what you mean by that. Total is actually 2210, which we don't worry about. Yeah, it's a, let me correct, Kalina, you're pretty close. Let me correct your grammar though. We call it the sample size. We only have one sample. So the number of samples is one because I took one sample. So we call it the sample size, which is how many data values are in that sample. Does that make sense? Whereas number of samples is just one, we took one sample. But the sample size was 16. Okay, I'm guessing the next one, you can all tell me what that means. Min x equals 1. Any guess what that means? It's important, but easy, so I don't have to spend time on it. Any guess? Yeah, that's just the minimum, the smallest number of all the numbers that were put in. 1 mile from campus. The funny thing is, if I were doing this from home, I would actually be the minimum, because I live really close to campus. To give you an idea, I have not driven to campus in over 5 years, and I'm here almost every day because I just walk or ski in. Okay, then there's Q1. That's a new one for you. Q1 is really important, and that is the first thing we call it the first quartile. And what that does is we're going to break the data into 4 pieces. The lower quartile, the next, and the next. And that breaking point for the lower quartile, the lower fourth, is 7. So that means basically that 7 is the 25% of everyone was 7 or less. Any questions on that? I want to give you a technical, depressing warning. It's the weirdest thing I've ever encountered in mathematics, and that is America and the world doesn't agree on the formula for the quartile. So if you use a calculator, you're going to get a different answer than if you use a computer, even though they're both the quartile. And it's frustrating as can be because, like, get Get over it. Figure out a formula. So unfortunately, there isn't an agreed upon formula for the quartile. So I want you to know the idea that about 1/4 is there or below. Can you remember that? I don't want you to remember a formula because there isn't one, which is like the only thing like that in mathematics. Okay, let me hit the down arrow. Okay, this is not Club Med, by the way. Any guess on what med might be? This is something you also got in 4th grade. Yeah, that's the median. And what that means, it is the middle value, or if there's a tie if there's an even number, it's the average of the 2 middle values. So that means that 117 cuts this group right in half. Half of you guys are above 117, half of you are below 117. Any questions on that? Next, Q3. That's the 3rd quartile. Okay, that's very similar to the 1st quartile, but instead of cutting on that bottom 1/4, it cuts on the top 1/4, or we could say it's the 75th percentile. 75% is at or below that number. And also, unfortunately, just like Q1, Q3 doesn't have an agreed upon formula, but you should understand the idea of it. Any questions on that so far? Okay, so quartiles are important, and quartiles are special cases of percentiles. So if I said, say, 20th percentile, that means 20% is at or below that value. So let me give you an idea, and let me give you an example of percentile, or an example of something that's going to get into percentiles. So it's my favorite when I talk about myself and my daughter. My SAT score was 1,170, and my daughter's SAT score was 2,050. Whose SAT score was better? What do you think? Okay, I'm not seeing you all jump in. Okay, you're all saying my daughter, except it was a trick question. I think this should be really obvious to you all that I'm a lot older than my daughter, right? We took it at different times. It was a whole different scoring system. So a number like that is meaningless. Does that make sense? So now let's talk about meaningful data. Okay. My percentile, the percentile for my SAT score, okay, was 93rd percentile. The percentile for my daughters was 92nd percentile. Okay, now you can all understand who did better, right? Do you all agree? Right, I did better. Does that mean my daughter did horrible? No, my daughter did well. She got into Berkeley because she was in the 92nd percentile, so that means that only 8% basically did better than her. So she got into a good university, okay? And I got into UC San Diego, okay? Because I didn't apply to Berkeley because I didn't like it. But the point is that if you told the percentile, then you get a lot of information about what's going on. If you're told the raw score, you don't get much information. Any questions on that? Yeah, so that means, so let me give you one more example, that might help. Let's suppose that you're a nurse, okay? Let's say you're working with my brother, okay? And by the way, my brother is a birther. Anyone know what that is? He delivers babies for a living. Yeah, he's a doctor and he delivers babies all day long. That's all he does. Okay, he's a birther. Okay, and you're working with my brother. Maybe you're a delivery nurse or something like that, or his doctor, partner. And the baby comes out and it's in the 3rd percentile. What does that mean? What does that tell you about that baby? Okay, yeah, that baby is going to go to ICU. Okay, Not just smaller than average, but it is way smaller. Third percentile means that only 3% are smaller than that baby that was just born. Do you see that? So if it's a third percentile, it's really tiny, it's going to go to the intensive care unit because it's too small and it's a preemie and it needs extra special help. Is that clear to everyone? So it's really important to understand percentile. Okay, percentage is different than percentile. That's just a note. Okay, and then the last one here is maximum. I think you all know what that means. I don't have to spend much time on it. It is 500. I want to mention one more thing. I want to look at the person that was, see if I can find it now. It's always the hard part. We'll look at the maximum, 500. Okay, we want to see if that person is an outlier. Have you heard of the word outlier before? Okay, a lot of you have, some of you haven't. So an outlier means it's exceptionally large or exceptionally small. That's what outlier means. Now we're going to have a definition in this class that means an outlier will be a value that is at least or at or more than 2 standard deviations from the mean. So we want to find out if 500 is an outlier. So what I'm going to do is I'm going to compute what's called the z-score. So I'm going to go up a bit because I need some things. And I'm going to look at this as a population. So I'm going to take the mean. I'm going to take 500 and see how far it is from the mean. So what I'm going to do, and let me write this, I'm going to annotate, is I'm going to take 500, takes me a while to write this because I'm doing it with the mouse, minus 138, and I'm just going to round to 138. I don't want to do all the decimals. And that tells you how far it is away from the mean. Is that clear? Then I'm going to divide it by the standard deviation, and I'm going to call that the z-score. And the z is x minus mu over sigma, 143. And this is a very important statistic. Okay, I want to see if you guys can do this in your calculator. By the way, I will never take away your calculator. So what is 500 minus 138 over 143? Pop in your calculator. I want to make sure you get it right. And this is called the z-score, as Brenda asked. So let's see if you can pop this in your calculator and tell me what you get. And if you're your computer has a calculator, just put it in the Google search engine. It'll just tell you what it is. Okay, this is what I was worried about. It's not 499.03. Okay, you made a mistake. Okay, notice that 500 minus 138 needs to happen first, and then you got to divide by 143. That's how you read this. So you need parentheses around the 500 minus 138. Is that clear? So I'm glad you made the mistake now. This is the time to make mistakes. The time to not make mistakes is on the exam. Yeah, and what you get is 2.53. So what that says, you usually round, okay, so if you're going to do the assignments online, then you round to whatever they tell you to round. If it says round to 4 decimals, round to 4 decimals. So round to 2, round to 2. Does that make sense? On the midterm and the final, as long as you show your work, I'm happy. You round to whatever you feel like, but you got to show your work. Does that sound fair? How to get those numbers? 500 was the number, that was the maximum. I wanted to look at the z-score for the maximum. 138 was this mean, x bar, which is mu actually, because I'm thinking about this as everyone in the room, everyone in this group. And then 143 is sigma, which is the population standard deviation. The general formula, by the way, and unfortunately the calculator does not have this. You have to know this formula. You can put a note card if you want. Is z equals x minus mu over sigma. And if that number is bigger than 2 or less than -2, we call it an outlier. If it's bigger than 3 or less than -3, it's an extreme outlier. Those are the words we use. And you are responsible for those words. Any questions on this? It's kind of the first mathy thing we've done today. We actually had to do a math calculation. But it is one that we do a lot in this class. The z-score is important. Any questions at all on this? Okay, I want to do the next thing, and I'm going to do it with a computer instead of the calculator. I want to show you both. So I'm going to do a new share. And that's that one. Okay, so this is the spreadsheet program that I created, okay? And there are like thousands of people using it now, which is kind of cool. All you have to do, in fact, look at that, somebody's on it right now. I don't think it's one of you, Anonymous Sheep. Is the first thing you got to do is whatever data is in there, you need to get rid of it. There's a lot of it. I actually put this in. I was helping somebody with taxes, believe it or not. It's gone now. So you don't need to know the details. But I was helping someone do their tax filing using the spreadsheet. But we're not going to do that person's taxes. We're going to do another survey. So let's do another survey. And let's make this pretty simple. So let me ask you, how many college classes have you taken in your lifetime? So how many classes have you taken in your lifetime? By the way, I'm sure if I answered, I'd be an outlier. So type it in. By the way, it'll be at least one because you're in this class. And this one counts. So the ones you're in now count. So everyone has to have at least one. So put that in chat box. How many college classes have you taken? I'm going to type these in. 16, 15, 13, 30, 30. 20, 30, 27, 25. 11, 25, 37. 19. Any others? How many college classes have you taken? Oops, I just typed in, there we go, 24. Okay, I think I'm gonna call it and just say that's enough. Again, I just wanna show you how to get data. Okay, so the way I create the spreadsheet, the first thing is I tried to make it as easy as possible. Does it look easy so far, by the way? I typed in the numbers. Okay, now here's what you have to know how to do. You have to know how to move your eyeball. Can you remember how to do that? And move it over, and you'll see minimum is 11, mean is 23. Variance we're not doing much with this, in this class, but I put it there anyway. Sample standard deviation is about 7.6. The median is 24.5, et cetera, et cetera. Any questions on that? Okay, I'm going to show you some more things. This is called a histogram. Unfortunately, you can't use it on the midterm because in order to get this, you have to have online access, and I can't let you be online during the midterm because it's too easy for you to ask people, how do you do this problem? So sorry about that. So the only time you're not allowed to use this is the midterm and the final. The time you're required to use this or another spreadsheet program, but I tried to make this easy, is, and especially for project 1 and 2, is on your projects. You're required to not use a calculator. You have to use a spreadsheet. Okay, if you don't like this one, you can use a different one. But I really tried to make this simple because you can just read everything. If we wanted to find the z-score for the minimum, for example, the minimum was 11, then you just type in, see where it says change this? You type in 11. and hit enter, and there's your z-score, 1.58. Any questions on that? Okay, so note, by the way, 11 is not an outlier because the z-score is not smaller than -2. Any questions on that so far? Okay, and this has all kinds of stuff. It also has a histogram. What was an outlier? An outlier was something that had a z-score that was bigger than 2 or less than -2. Remember that, Hannah? Okay, that's how in this class we're calling that an outlier. An extreme outlier, we do 3 instead of 2. It means it's very unusual. Okay, wait, David, don't go yet. Let me give you a secret word. Otherwise, you're going to have to rewatch this. Hopefully, you can hang for about 20 seconds or till I can draw this. Let's do text, I think. Put this in. Oh, it does allow me to do text. That's new. And the secret word is sigma. I try to pick things that are important, but are not obvious. Like you probably wouldn't have guessed that would be the secret word today. Sigma, by the way, who remembers what sigma stands for? What are the words for, what does it mean? It's a parameter, but which parameter is it? It's not summation. That's capital sigma, it turns out. So I'd had to use capital S for that. Should I tell you? I told you it was really important in this class. That was a hint. Population something. Do you remember? Population standard deviation. Population standard deviation is sigma. Any questions on that? Yeah, so sigma is a secret word. When you go to the secret word quiz, you type in the word sigma, and you've got it. And now if you have to go, you can go, David. But I want to make sure you have secret words. You have to watch this again, because I'm not going to go more than 15 minutes longer. Okay? But I do want to go a little bit more because I want to show you some more charts. Okay? So anyhow, this is a histogram. I don't recommend you leave because I'm about to talk about charts, and charts are important. But if you have to, you have to. And what this does is it gives you kind of a visual representation of the data. What's nice about histograms is that most just general public knows what they are. Most people know how to read it. So we can see that there were 3 people that had answers between 10 and 16. There were 3 that had answers between 16 and 20. There were 4 between 22 and 28, etc. Any questions on the histogram? Okay, this histogram is actually approximately uniform, which means it's pretty flat. It's almost the same for everyone. It's not perfect, but you're never going to get a perfect anything distribution. So uniform means flat. If it looks, let me show you. I got to do a draw on this one, though. It's not that far from being like this. This is the most normal, the most important distribution is called normal. And it's not that far from being normal either. It's kind of in between uniform and normal. So if it looks like that, like I just drew, then we call it a normal distribution. Okay? If instead it looks something like that, where it kind of has a tail on the right, then we call it skewed right. Whereas if it looks like this, where it has a tail on the left, let's go down a little more. There we go. Then we call it skewed left. Okay? So again, there's uniform, normal, skewed right, and skewed left. Those are the important distributions that I want you to kind of get in terms of their shapes. Any questions on that? Okay, if it looks like this, we call it bimodal. Whereas the others are called unimodal. Bi for 2, like bicycle. Uni for 1, like unicycle. How do you spell that? I think you mean skewed. Okay, so let me put in text on that. So skewed is spelled S-K-E-W-E-D. And again, all this is in the book. And it's also in the videos. And the videos are all closed captioned. Yeah, bimodal is the fourth because it's got two humps. 2 high points is bimodal. Whereas our example is unimodal because there's only 1 high point. Do you see that? And that's the 22 to 28 group. Okay, I think I want, let's see, now I got to figure out how to do this. Let me clear all drawings. So I'm going to clear these so we can see again. I'm going to go to stats. Oh, shoot. Clear all drawings. There we go. I'm going to go to stats again. And I'm going to go to box plot. Now, I want to let you know if you use this, it's going to give you all kinds of warnings about a virus or something attack. I did not put a virus. I'm not destroying you. I promise. But for some reason, computers like worry about this. This is called a box plot. And this, what it does is it displays what's called the 5-number summary. Okay, so this is called the 5-point summary. And you'll notice 11 was the minimum, 37 was the maximum, 24.5 was the median, 16.75 was Q3, Q1, and 29.25 was Q3. So what this is it is a visual of what's called the 5-number summary, which are 5 important statistics, all in one picture. Any questions on looking at this box plot? Okay, some issues with the box plot. One is that if you show this, if you present this to a general public audience, you're just going to confuse everyone because they don't know what one is. Okay? But the interesting thing, if you show it to a 10th grader, they'll all know what it is. I went to stats, box plot. And when you do it, it's going to give you all kinds of warnings. And you just got to accept the potential of getting a virus. I won't give you a virus, I promise. Okay, so that's the box plot. And if you go to stats, and you go to stem and leaf, okay, then this is a stem and leaf plot. What I try to do is make it good for all of these visuals. So notice there's all these words and stuff. That's for people with visual impairment, because this is a picture and this is typing, which means that they'll be able to hear this on a screen reader. So you don't have to look at this in the bottom part unless you have a visual impairment. But the top part is the stem and leaf. And what that does is you pick your stems and leaves. And right now, by the way, the stems are 10s and the leaves are 1s. So the way you read this, for example, this 9 right here means 19 because this 1 and a 9. Okay, the good thing about stem and leaves is that you can get all of the data values back, whereas with the histogram, you can't. You can't know that there was a 19 in the histogram because you just know there are 3 between 16 and 22. So the stem and leaves allows you to see the distribution, the shape. You can see it's kind of flat, and you can get your data back at the same time. One of the big problems with the stem and leaf is that if you had, let's say we had, instead of a sample size of 14, we had a sample size of 20,000, you have to be able to fit 20,000 numbers there, and you can't. So it doesn't work for very, very big sample sizes. The other problem with the stem and leaf is that for presentations, number phobes hate this. You guys know what a number phobe is? Anyone know what a number phobe is? Okay, it's someone who's afraid of numbers. Yeah, it's a phobia of numbers. People who just shut down when they see lots of numbers, and there are a lot of people like that. So you got to be careful about, using this in a presentation, because people who hate numbers are going to hate this diagram, and they won't mind the histogram. So that's just suggestions. Presentation style is important, and it is part of statistics. Okay, this is a stem and leaf, and again, I could have picked, if these were 3-digit numbers, I would have gone, where is it? Let me remember. S and L left 10, 2, and if I put a 2 there instead, then what it'll do is it'll round to the nearest tens, and it'll give a stem and leaf on the hundreds and tens. Now, that's not very interesting if everything's a 2-digit number, though. Any questions on this? Stem and leaves also don't work well if you only have 1-digit numbers, because there aren't 2 digits to look at. Okay, so that's a stem and leaf diagram. Also kind of nice. I use it when I grade, actually, because it gives me an idea of how many A's, B's, C's, D's, and F's there are. Because I know that if it's next to a 7, they get a C. If it's next to an 8, they get a B. If it's next to a 9, they get an A. Do you see how that works? So it's actually really good for grading, because I get a really nice view of what the grades are. Any questions at all on the charts? Okay, there are some other charts I didn't bother with, but if you want to, and I think Google actually does it. I didn't make it easy because it's not that important, but you could do, let's see if I can find it, but you could do a pie chart. And you've all seen pie charts, so hopefully I don't have to go over pie charts. Okay, so Brenda, this is not Excel. This is Google. And if you're wondering how to find it, let me show you. If you go to the modules, and you go to Project Spreadsheet Resources, it's the first link. And you click on that. This gives you instructions on how to use it. And right here, this link, this big, ugly, long link, that sends you to where we are now. Okay. You will have to go to File, make a copy for your very first thing you do. I'm not going to make a copy because I don't want another one of these. Because the way Google works is, the way Google Sheets works, is that you can share this with lots of people, and you can all be looking at the exact same one. And if you change the data, they all see the change. So when you're working your project, you want to work on one Google Sheet and share it with each other. And there's a share button, and you just hit share, and then send the link of the copy that you made. Does that make sense, Brenda? Okay. I do want to note something, that there's these other tabs, 2VAR-Stats. That's project 2. There's regression. That's chapter 12. Chi-squared, chapter 11. ANOVA, that's chapter 13. I call data lists. That's going to be in chapters 8, 9. Let's see, that's 8, 9, and 10. And there's compute, and that's going to be in chapters 4, 5, and 6, and 7. Okay, so just a note is that I made sure that pretty much everything we do in this class is available with the spreadsheet, except you can't use it on the midterm and the final, sorry. I'm trying to figure a way to make it work, but I haven't figured out a way yet. So that you could do that, but you can't like email each other and say, how do you do this problem? Any questions on this? Very good question, though. And again, it's not Excel, it's Google Sheets. I don't use Excel because Excel is a private company that, Google's private too, but Excel could possibly cost. There are free ways of doing it. I like Google because when you're not a student, you can still use this for free. Okay, any other questions? Okay, what I'm going to do is that's pretty much enough. Again, there's some other little details that are important in the chapters. I can't go on for 10 hours or whatever, but I'll let you read through that. But I gave you the main things. And by the way, your project is going to kind of look like the survey we just did, except you're going to have to do a either stratified or you're going to have to do a cluster sample, which now you know what those words are. But by the end of the week, you'll know it a lot better because then you'll be tested on it and you'll practice and you'll have discussion posts on it and stuff like that. So again, what I always do is I will hang out here until either you're all gone or it's clear that you're not paying attention anymore, or you said thank you and goodbye or whatever. But I'm here to help out. If you have any questions, this is a good time. I'm going to stop the share so we can all see each other. And again, the secret word was embedded. I try not to do it at the very end, by the way, so it's kind of nice. What you do with the secret word, I can show you if you want. Then I got to reshare. It's very easy, I promise. Let's go there. And in the modules, okay, don't say what the secret word was because, again, that happened a little while ago, and I want those who are watching this to not just go to the end and see it. But you'll see week 1, secret word quiz. You click that. You won't have to hit preview. It'll just show up for you. And you type in the secret word. You hit submit quiz. So I tried to make it easy. That's it. That's all you have to do. Okay. Any other questions? What was the word? I'm not going to say it now. You were supposed to write it down when I said it. But I said it. I'll let you go through. This will be on. Yeah, if someone else wants to private message Alejandra, you can do that. I'll let you do that. But if I say it, then everyone goes to the end and they just hear the secret word. I try and put it somewhere kind of in there, not hidden, but just somewhere in the webinar. I want people to watch the whole thing, basically. You tried it, didn't work? Let me unshare and let me double check. Because I just put that in today. Let me check again that you're not going to see it. Because there's some stuff in here. Let's go back. Just a minute. It should have worked. Double check again. Oh, it didn't save. I hit save though. All right, try it again. I just hit save. Now it should work. It better. Let me know if it didn't work. So try it again. It should say correct. Try it one more time. I think it's set. You can do multiple tries. And tell me if it works. Still says incorrect? All right, let me be a student. Just a minute, launch student view. It's not all caps, but I don't think it's case sensitive. Let me go put it in. Mine worked. Yeah, 1 out of 1. It's only 1 point. Because remember, it's all or nothing. You get it? If you don't do it, you got to write a 5-page paper. So you want to do it. Yeah, it should say 1 out of 1. It should work now because I did it in what's called student view, which means I could pretend I'm like you. And it worked with all caps. Okay, yeah, I'm pretty sure Canvas is not case sensitive. This is Canvas. And it's not case sensitive on quizzes. No, I did all lowercase. Maybe you spelled it wrong. I just tested it and it worked for me with lowercase. So check your spelling. I'm not sure if it'll matter now because I think you've already taken it. I don't even know if it'll let you take it once you get it right. Yeah, so it should work. I bet you had a typo. Okay, it does allow you to try more than once. So if you have a typo, you can fix it. Any other questions? Any other questions? Again, I'm here to help you out. If you had any questions, this is great. Next week, I'll probably talk about the project, by the way. So that's an important one. Let's see. What would you say is the best way to learn the material? It's hard because you're you and I'm me. But reading, watching the long chapter videos, you must go to the webinar. And then make sure that if you get a problem wrong, you redo it and get it right on the assignments. Okay. So if you have a request for next week, you post it in the Q&A form. And then other people can say yes or no, you know, that you'll like it, and I'll take the majority. Again, I can't make it on Monday from basically from 1 to 3. I guess officially noon because it's office hours, but definitely not 1 to 3 because that's when I teach my other class. But I think the rest of my schedule is pretty open next week. I like to do it on Monday or Tuesday so you have enough time to be able to get all your assignments done and stuff. Yeah, writing notes is a good idea. Okay, treat this like you would a regular lecture. Writing notes is helpful. Let me double check my schedule. Next week, yeah, on Monday and Tuesday I have nothing. So again, I'm flexible, but I need to hear a second when someone suggests something because there's a lot of you. So put it on the Q&A and see what happens. Okay, any other questions? See if I missed any. Yeah, it's hard to say, is it a review? Well, what I'm doing and what the chapter does and what the other lectures, they're the same things, but just a different way of learning. So it helps to have multiple ways so you get it. Oh, good. I feel the webinars are really important. Otherwise, I think I'm cheating you out of an education. If I just say, go read the book, that's your whole class, then I'm not here for you. So this is one big way that I can help you out. So I'm glad that they help. And again, I'm glad that you guys are participating. You can talk too, by the way. But you're all using chat, which is fine too. Where's the Q&A? Okay, I can show you that in a minute. Let me student view, just a minute. And let's go home, just a second. And just a minute. I have to go share. Takes a second to get it set. There we go. Okay, so to find the Q&A, you go to home or modules either way. Go to discussions is the easiest. You go to discussions. And what I have is I have them pinned. So Q&A is right here. You just click on it. And there's already been 7 Q&As. And I recommend reading it because I'm often answering questions that are going to help you also. So I have what's called the pinned discussions, which means all the discussions that are of interest to you this week. And I tend to keep it pinned until I graded it. It usually takes me a day or 2 to grade for the assignment discussions. And you'll notice these numbers. That means there's 14 I haven't seen yet because they probably happened in the last, since I started the webinar. And 14 of these and 2 of these. So hopefully that answers your question. Okay, with the survey design is a big topic. So you might want to read through the book and also watch the other video. And then specific things that you're confused on, why don't you post them in the Q&A, and then I'll give you written description. I think that's the best way. The other video, let me go back to share again. Okay, so the other video is, if you go back to modules, and you'll see full-length video on chapter 1, and that's where the sampling technique is. Hopefully that makes sense. And then you click that, and it'll just happen. And you click play, and there we go. You'll notice a systematic, convenient, stratified cluster. So I've got all those things. Okay, hopefully that makes sense, Hannah. I know there's a lot, in the first week there's a lot to learn in terms of like how to find things. But you'll get used to it. Again, go through module 1 and go through step by step. You'll see everything you need. Any other questions? Allison and Alonzo and Alex and Hannah and Brenda, Constance? Any questions? Okay, have a good night, Brenda. Okay, have a good night. And again, if you have no questions, then you could leave if you want. You just hit leave meeting. Okay, have a good night. And Allison and Constance? Okay, have a good night, Constance. And let's see if Allison said good night. Allison, any questions? You're the last one here. Give you a little bit of time in case you have them. Otherwise, we'll say good night to everybody. Okay, I think I'm going to call it. All right, so all of you are watching this as a recorded video. Have a great week. Please post on the Q&A forum any questions you have about topics from chapter 1 or 2, or any other general class questions. Post on the project discussion board, Project 1 discussion board, to make sure you get a partner. And I'm here to help you out. So have a great week. Take care.